I want to give a very high level overview of MonsterMQ and its architecture, because I think that is really important to know how MonsterMQ works. So here we have my 24/7 hours running MonsterMQ at home. And important to know is, first of all, you must define at least one database connection in the config file. It can be MongoDB, it can be a PostgreSQL timescale, it can be SQLite, and also CrateDB. And then you can choose to use one of these for the internal data store of MonsterMQ. It's important to know that like retained messages, the subscriptions, also the configuration, everything is stored in one in a database. And for that you have to define a connection to a database, like again MongoDB, PostgreSQL, SQLite in the config file. You can also define all three, and then you can choose which configuration is stored where. But typically session store, retained messages, device configs, or the configuration, typically those things are stored in the same database. So in my case, I'm using here PostgreSQL, but still I also have a connection configured to MongoDB. Why? Because we have here these archives, and an archive is a first-class citizen in MonsterMQ to store data, to store the last values, the last well-known state of a topic, value of a topic. But not only the last value, it can also write a history value, archiving it to a database. And there you can choose one of these configured databases, what you configure in a database. But that also means there's only one destination for each type of database. And as you can see here, typically the default is the default archive, and here I have a hashtag, so meaning all of the values are going into this archive. This is fine if you have a small or mid-sized broker, then it doesn't matter. But if you have running an enterprise level broker, we are maybe talking about 10,000, 30,000, 100,000 messages per second, then you have to think twice about not to store all this data, first of all in memory, but also not historize all the data. But anyhow, if we are talking about 10,000 value changes per second, it typically doesn't matter, the database can handle that well. And yeah, typically I'm storing the last values in memory. So with that done, we are able then to query the current state of a topic, get the last known value. And as you see, my broker is using PostgreSQL to store the configuration, to store the retained messages, to store all the subscriptions and so on. But for historical values, I'm using the MongoDB connection. Why? Because I think MongoDB is really great. First of all, if you have, in my case, I'm typically using JSON as a payload, and MongoDB fits perfectly for that. Also Postgre is really good on that. But also MongoDB, MonsterMQ is leveraging the time series feature of MongoDB, and this compresses the data really very great. So, and one of the main differences between the archives and the loggers, to which I will come later, is that an archive is again a first-class citizen. That means we also have functions, we have REST API, we have an MCP server, we have GraphQL, and there we have the option to first of all read the current state of topics, then we are accessing an archive, and also to read the historical values of topics, and then again we are also reading it from the archive. And this is built in, again, a first-class citizen. Loggers is for write-only data to external databases, and here we have also buffering, so store and forward. You can choose between store and forward in memory only, or maybe store and forward, store it to disk if the remote database is down. And also here we have the option to convert, for example, JSON data to columns in a relational database. And here we have currently some different type of destinations: QuestDB, PostgreSQL, Timescale, MySQL, Snowflake. Yeah, to where we want to write the data to. And also this list will get extended with other databases. So, and the third part is then bridging. So bridging is like connecting devices to MonsterMQ, OPC UA clients, MQD clients, NUTS bridge, Mindsys UA, getting data from Mindsys UA, getting data from Mindsys Unified, PC4X. So here there you can also get data from Modbus devices, from, I don't know, S7, whatever kind of drivers are available in PC4X. On Neo4j, or there's a Spark B decoder where you can define if you have Spark B messages coming into the broker, then sometimes we want to make it human readable, then this decoder can help to decode the binary encoded Spark B messages to JSON messages. And yeah, so that are the main differences between where data is stored. Is it configuration data? Is it historical data? Is it last value store? Is it a write only, where we using MonsterMQ to forward data, current data, to historians or to databases? And those are workflows. Yeah, also workflows, for example, can read data, current values from topics, but also historical values of topics from the first-class citizen, again from archives. So I hope this helps you a little bit to understand how MonsterMQ works.